Hi, and welcome to the wonderful world of Sam's Geometry. I'm Sam. In this lesson, we'll be covering Unit 1, when we'll be learning about polygons, circles, and some other stuff you probably don't care about. Now, the first thing we're going to learn is polygons. Polygons are closed figures in a plane, formed by connecting line segments from endpoint to endpoint, with each segment intersecting exactly two others. Now, you may be thinking, what the heck does that mean? Well, that means for each polygon, each polygon has at least 3 lines, and each of those lines has to be touching 2 of the other lines. Makes more sense that way, right? Yeah, I thought so. So, I have some example polygons here. This is an example of a polygon. This is an example of the polygon. This is not an example of the polygon, so screw this. The next thing we'll be talking about is classifying polygons. 3 sides is a triangle, 4 sides quadrilaterals, 5 sides pentagons. I'm not going to go on with this. The next thing is naming polygons. You name polygons by listing the vertices in consecutive order. So let's say this was A, B, C, D, E. I would list A, B, C, D, E, or E, D, C, B, A. But I can't list it A, C, B, or some random other crud. Diagonals. Diagonals are the line segments in between two non-consecutive vertices. Oops, I just screwed up. So, if this was a point right here, it's connected to these other points. So, the diagonal between this point is this point. Makes more sense. Concave and convex. In science, I learned concave means it looks like a cave, so it goes inside. So it would be something like this. Well, in math, in geometry, it's something completely different. Screw science. In math, in geometry, it basically is all the diagonals have to be inside the shape for it to be a convex polygon. So this would be an example of a convex polygon because all the diagonals are inside this little pentagram thingy. But in other cases, concave, there are some diagonals that are outside this shape, like this thingy here. So this shape in here, this diagonal here would be outside, so it would make a little triangle looking thingy. Moving on. Congruent polygons. Congruent polygons are 2 polygons that are exactly the same shape and same size. Oh no, I don't have any. So if this was here in Tangram, there's 2 of these thingies, so they would look exactly the same. You put them right next to each other, they'd be exactly the same size. There'd be no overcut or anything else. So they look the same, they have the same angles, they have the same exact measurements on each side. Moving on. To show that 2 shapes are congruent, you have to lift the corresponding vertices in the same exact order. So let's say it was A, B, C, D for one thing, and the other one's E, F, G, E, F, G. So let's say this is A, B, C, D, and then pretend this is the same thing. E, F, G, D. E, F, G, H. So on. You have to list these in the exact same order, and to prove they're congruent, you have to do that equal sign with some random swirling line on top. Going on. The perimeter. The perimeter is the sum of all the lengths on the sides of the polygon, of each side of the polygon. I'm pretty sure you already know this and you don't want to hear this anymore, so I'm going on. Equilateral polygons are polygons that have the exact same side lengths, so all the sides are congruent. Equiangular polygons are polygons in which all the angles are the exact same measures. Regular polygons. These are going to be shapes that are both equilateral and angular. Man, I can't say it today. That means the square would be in example because all sides are 90 degrees and all the sides are the exact same measure and all the angles are the exact same measure. So, but some shapes like rectangles won't work. They may have the same angles, but they don't have the same sides. Going on. Triangles. When I went to Mrs. Choi's room the first day, she told me not to assume. So just a warning, if it looks like that's a triangle, you might be wrong, it's a square! triangles. Right triangles have exactly one right angle. Not that hard to remember. Acute triangles are triangles in which all angles are less than 90 degrees. Also pretty easy to remember. Obtuse triangles are triangles that have at least one obtuse angle. Also really simple to remember, so I'm not going to talk about this anymore. Now about side lengths. Scalene triangles are triangles in which no sides are congruent. Every side has its own business going on. Equilateral triangles are triangles in which every side length is exactly the same size. An isosceles triangle is a triangle which at least two sides are congruent. That doesn't mean only two, it means at least two. So if it's an equilateral triangles are isosceles triangles. So get your facts right. In the parts of the isosceles triangles, there are several different parts. The vertex angle is the angle opposite from the side length that's different from everything. It's the vertex in between the two congruent sides. I mean, the base angles are the angles on the base. The base is the side opposite from the vertex angle, and the base angles are the angles connected to it. Quadrilaterals. Trapezoids. This is an example of a trapezoid. And trapezoid is quadrilateral with at least one pair of parallel sides. And this thing here says a trapezoid is quadrilateral with exactly one pair of parallel sides. Well, this is wrong, so screw this. Kites. A kite is quadrilateral with two distinct pairs of consecutive congruent sides. So that means that if there's one side here, the side that is touching exactly has to be the same size. And it has to have two different sizes. So it looks like the kites that you usually fly around. Parallelograms. Parallelograms are quadrilaterals with two pairs of parallel sides. So that means squares would be parallelograms and rectangles too. Yeah. Rhombuses. Rhombuses are, well, equilateral parallelograms. So they'll be like squares and stuff. Rectangles. Rectangles are equiangular parallelograms. So squares are included, but nothing that's slanted. It has to be right angles. So the rectangle, the original rectangles, and the squares. Squares. Squares are equilateral rectangles. They're also equiangular rhombuses. And they're also regular quadrilaterals. Gosh, there's so many terms for this one thing that's so simple. Segment addition. If B is between a point A and a point C, then section AB plus section BC would equal line segment AC. Angle addition. Same concept here. If angle D is between an angle ABC and A is between an ABC and ABE, then wait. Scratch that. If line segment C is between the interior of AOD and then the measure of angle AOC plus the measure of COD would equal the measure of AOD. Same concept. Moving on. Circles. Now you may be thinking, why do we need to learn about circles? Well, take it this way. A circle. This is a semicircle, which is half a circle, right? I screwed up. And this is a circle, a perfect circle, right? Well, you're wrong, because this is 3D. The circles are a set of points in a plane at a given distance. which is the radius of a given point. So it means every point is the exact same distance from the center point. And you name a circle by naming its center point. So let's say there's a circle called circle A, and the radius would be 1 centimeter. That means every single point around it is 1 centimeter across. Moving on. Chords. Chords are line segments which endpoints lie on the circle. And by on the circle, it means by the edges, the line thing that you always see. And it can be anywhere. The diameter is the longest chord on a circle. Radius. I just talked about this. Radius is exactly half of the diameter, and it's a segment from the center of the circle to another point on the circle. Moving on. Tangents. Tangents are lines that only intersect the circle exactly once. So basically it just touches the circle. It doesn't go through the circle. It doesn't go do anything of that random business. And then going on with tangents, common tangents are circles that touch 2 or more circles. Well, a line that touches 2 or more circles. There can be 2 kinds of this. External common tangents are tangents that touch the outside of the circles but does not go in between them. Internal common tangents is a tangent line that goes between 2 circles. Congruent and concentric circles. Congruent circles are, well, circles that have the exact same radius. Concentric circles are circles that have the same center, like this fan right here. Oops, I broke it. This circle here, there's a smaller circle here, another circle here, and another circle out here. So, makes sense. And about that, it feels really good too. Going on. Arcs. Arcs are 2 points on the circle, and a continuous part of the circle is between the 2 points. So it's basically like a curvy line segment. And there's different kinds of arcs. Semicircles are basically arcs. That are the endpoints lie on the diameter of a circle. A minor arc is basically smaller than a semicircle, and then there's another arc called the major arc, which is larger than a semicircle. And to name semicircles and major arcs, you have to use 3 points. So let's say there's a circle with a circle D or something, and then there's the diameter points A and C. To name it, you have to have another point between those 2 points to name a semicircle or a major arc. But minor arcs, you only need 2 points, so who cares? And arcs are measured in degrees. A full circle is 360 degrees. Not like you didn't know that, I hope. And semicircles are 180 degrees. If you disagree with me, do the math yourself. The measure of any minor arc is equal to the measure of the central angle, because essentially it's just an angle that's been zoomed into. Moving on. Space geometry. Space. What is space? 2 answers. 1, it's a concept of going into the stars and having everything from random planets to stars and anything in there, and who cares? But we're talking about geometry, so science lies to me a lot. Space is a set of all points. It's 3-dimensional. It's a set. So multiple points on one tiny. Infinitely many points equals a line. Infinitely many lines equals a plane, and infinitely many planes equals space. There's 6 types of geometric solids. There's cylinders, cones, pyramids, prisms, spheres, and hemispheres. How to draw cylinders. If you want to figure out how to draw, go ask an artist or go on to Mrs. Choi's websites. And last concept, the premises of geometry. The properties of arithmetic are basically the commutative property of addition and multiplication, the associative property of addition and multiplication, and the distributive property. But you guys already know this, I hope. And then there's a bunch of other stuff that I can go over, but you guys can figure this out yourself, I'm pretty sure. And that ends my first session of Sam's Geometry. Next time I'll try to have my little brother to help me with a bunch of other stunts. Well, it's been nice knowing you guys, and well, have a nice day.